Hello, colleagues. My name is Peter Lowen, and it's my pleasure to talk to you today about 4 obstacles to algorithmic government. What I want to do over the next few minutes is to share with you research that I've done with my colleagues, Benjamin Allen Stevens, Dario Sigiu, and Bart Bonakowski, work funded by SSHRC, by the Public Policy Forum, and by the Schwartz Reisman Institute. And what this work is interested in doing is understanding what the barriers are to citizens accepting government using algorithms to make decisions. I want to share with you 4 particular barriers that we think stand in the way of widespread citizen consent for the use of algorithms in decision making by governments. What really motivates this set of questions in these investigations are the following central questions. Why don't we automate more decision making in government? Why do we leave it to humans to make the same decisions over and over and over again when those decisions could be made with much more rapidity, perhaps with more consistency, and maybe with less bias if they were made by machines? The second central question is, what are the potential obstacles to algorithmic government? Well, what I want to show you is that there are 4 particular barriers to the widespread adoption of using algorithmic government from the perspective of citizens. These barriers are important, and they're barriers that will have to be overcome if we want to use automated decision making in a way that is consented to by citizens on a much wider scale within government. So the roadmap for this talk is the following. I'm going to make my own case for algorithmic government. That is, I'm going to tell you some of the reasons that I think we should perhaps use more algorithms in government or more automated decision making in government. To be fair, I'll discuss the other side of the ledger as well and articulate to you what I think are some of the limits to the use of algorithms in government. I then want to make a particular argument about what I call the centrality of citizen consent. The basic idea here is that if government's going to change on a large scale how it does something, it ought to do so with the consent of citizens. Not in a simple way, but in a way that deeply considers several dimensions on which citizens may or may not object to government doing something. And having set that table, I'll then talk about 4 challenges of citizen consent as obstacles to algorithmic government. In essence, what I'm going to do is to present to you 4 different reasons that citizens may be reluctant to consent to government using algorithms. So what is the case then for the use of algorithms in government? Well, here are just some arguments for why we might want to automate a larger number of decisions that bureaucrats make. The first is that the administrative state is becoming more complex, not less complex. Every year, as we pass new legislation, bring in new programs, implement new policies, another layer is put on top of the administrative state. And this is not an argument about government being inefficient or government not doing its job well. It's just a statement of reality that government is becoming more complex and not less. Organizations which are more complex should at some point strive for simplicity. And one form of simplicity may be in trying to automate decisions rather than leaving them to humans to make them. The second thing, which is related to this, is that we regularly rely on bureaucrats, and that is to say humans, like you and I, to make a massive number of decisions and implement policies. The challenge here is that there really are clear and demonstrable limits to how well we can make decisions. Humans have trouble making decisions consistently. They have trouble regularly and consistently rooting their decisions in the values or the objectives of a policy that should be motivating those decisions. Humans are biased. And more than that, humans are good at lots of things. We're particularly good at judgments. So if we're able to think about the whole schedule of decisions that you might make as a bureaucrat and break apart the ones that are more routine and automatable and rote, and the ones that require judgment, why wouldn't we want to dedicate more energy to the ones that require judgment, or maybe an element of morality even, than the ones that are more rote and routine? The third consideration is that more procedurally fair processes do not necessarily or even probably lead to better decisions. I want you to understand this in the following way. There's a very good example from the United States, which is that there's a large number of veterans in the U.S., and there's a very good example given by our colleague Dan Ho, that the Veterans Administration in the United States has decided that when veterans have some objection or some appeal to the benefits that they're receiving, that they should be heard by a human judge. Now, this is motivated by the idea that we think it's just and fair that if we have a problem with government, a human ought to hear our problem. But there's a scale issue. There are so many people appealing their benefit allocations that the amount of time that a judge can give them is just 5 minutes. So what seems procedurally fair, putting someone in front of a judge and letting a human hear another human's case, may in fact lead to worse processes because there's simply not enough time to do it well. But even when there is enough time to do it well, the data is relatively clear and the research is relatively clear that humans are not consistent in making their decisions. So we often bring humans into our decision-making processes because we want them to seem procedurally fair, but in fact, they may be less fair than if we had a machine making a decision. The fourth case for algorithmic government is that the state is not designed to learn. If you're making decisions at a very rapid clip and then moving on to new ones, and not building in time for reflection, the degree to which you can learn from the data you're producing in the decisions which you're making, the degree to which you can learn, or any bureaucrat can learn, whether their decisions led to good outcomes, and then to update their mental models and update how they're making decisions, is deceptively difficult, even when time is set aside for it. But in a state that is increasingly complex and has an increasingly large number of decisions to make, it becomes near impossible to actually learn. So when you take these four considerations together, what comes out of it is the possibility that some degree of algorithmic decision-making may be able to address these shortcomings of how we're currently making decisions in the administrative state. Having told you about the potential benefits or reasons for using algorithms, let's acknowledge that there are some limits to the use of algorithms, and these are equally important. I want to give you just 5, and then I really want to focus in on the 5th one. The first is supervision, that it's hard if we automate a large number of decisions to be able to effectively audit or supervise all the decisions that are being made. More difficult than if decisions are being made more slowly than humans. The second potential limit to the use of algorithms is the classic problem of principal-agent problems. If I'm the principal in a relationship, I have something that I want you to achieve as an agent. I empower you to do that. But if I can't supervise you in doing it, the whole notion is that I delegate to you because you have more time than I do to make the decision, then there becomes a gap between what I want and what you do. This is a classic problem in any large organization, in fact, in any organization which involves delegation. But there's a potential that it's even worse with algorithms if we allow algorithms to learn. Because if we can't see how algorithms are learning and changing the way they're making decisions, then that widens the gap potentially between what the principal wants and what the agent does. There is the problem of explainability, that what is happening under the hood with algorithmic decision making, especially if algorithms are learning in real time and are adapting how they're making decisions, is important to be able to explain to citizens. Citizens reasonably want justifications for the decisions that are made by public officials. And if decisions are left in the black box of an algorithm and we can't explain them, then we miss a fundamental value of public decision making. Fourth, there is the challenge simply of implementation. Large national governments, large provincial governments, large municipal governments all have the problem, which is well known, of actually disseminating technology and technological solutions throughout their workforces. This is equally true, maybe even more true, of algorithmic decision making. We can imagine ways in which algorithms will make decisions. Getting them implemented into people's workflows is another matter. And there's a 5th obstacle, which is the one I want to focus on for the balance of this talk. And that's the idea of citizen consent. The idea that what government should do should only be what citizens would consent government doing, and maybe what they would consent government doing on reflection. So let me talk now a little bit about the centrality of citizen consent for government decision making. The first claim I want to make is that in the long term, citizen consent is fundamental for the effective functioning of government. The secret of democracy, the reason why it works better than other systems, is not because citizens are perfect supervisors of government, but that they are, over time, able to rein in governments who go too far and able to push governments who aren't going far enough. At the core of that is the idea that citizens are consenting to what governments are doing. Indeed, citizen consent is tied to a whole number of assumptions and norms about how government and about how public service should work. Third, opposition to government action is powerful. even if that opposition is only held by a minority. So imagine, just for a moment, that most citizens couldn't care less about whether government uses algorithms or not. But there's some minority, 10, 15, 20%, that care deeply and are very exercised by the proper use or by limiting the use of algorithms by government. How can that 10, 15, 20% act as a check on the greater use of algorithmic government? Well, they have first the potential for activating greater opposition, that a well-motivated small group could be able to light up more public opposition. The second is this related idea of issue publics. And the idea here is that we don't have one public, we have several, and those publics are defined by the issues that they really care about. And if you want to have continued government consent, you have to build up consent with the building blocks of those different issue publics. So for the 10, 15, 20% of people who really care about how government makes decisions, for them, the use of algorithms may be fundamental to their consent. So even though they're a small group, those are the terms on which you have to seek their consent. And finally, government success depends on attention. You know in your departments, you've probably had examples or experiences of this, where when public opposition and the spotlight of public opposition focuses on one department, it can really slow down what that department does for a long time. Sometimes it can stop whole programs, good programs, right in their tracks. So government success depends on its ability to focus on things and get them done. And when it faces opposition, even opposition from a minority over some issue, it draws away from the ability of government to get done what it wants. What I want to highlight for you now is that our research suggests that there are 4 challenges for citizen consent to algorithmic government. That is to say, there are 4 particular things, maybe there's more, but we've identified 4 particular things about the use of algorithms to make decisions which may not be fully consented to by citizens. That is to say, these represent fundamental obstacles between where we are now and the further use or the greater use of algorithms and artificial intelligence by government. I'll talk about them more in detail, but here they are in sum. The first is that citizens support a lot of different reasons for the use of algorithms, but they support no single coherent set of justifications strongly. The second is that when you ask citizens to evaluate any algorithmic innovation, they'll always evaluate it negatively versus the status quo. That is to say, if you describe to them the way decisions are made now and the way they could be made with algorithms, it seems that they always prefer the status quo. Third, citizens' trust in algorithms develops independently of algorithmic performance. This is a fancy way of saying that citizens are very harsh judges of algorithms, and they're just not likely to extend them their trust. I'll show you some experiments we've used to measure that. And finally, opposition to algorithmic government is higher among those who fear the broader effects of automation and AI. Government is not operating isolated from the larger, big super forces that are changing the way our society is organizing itself. And to the degree that there is a broader opposition to automation and AI, that broader opposition underwrites people's opposition to government using automation and AI. So if we want to know what citizens think about algorithmic government, our view is that the best way to learn that is to ask them. So what we want to do is present you with results from studies that we've conducted in several countries. Now, these studies rely on data collected through online surveys, conducted on broadly representative population samples. And the results that we're going to show you don't really depend on weighting or any kind of strong statistical corrections. It's a long way of saying I want you to trust me that these results are representative of the populations where we've taken them. The data we want to present to you comes from a number of countries: Canada, the United States, Australia, Austria, Belgium, Flanders and Walloon, Denmark, Finland, France, Germany, Greece, Italy, Ireland, the Netherlands, Norway, Portugal, Spain, Sweden, the United Kingdom. And there's a second set of studies that we conducted in Canada, US, and Australia in 2018. Our European data were collected in the spring of 2020. And what we're going to do is present you with results where we've conducted experiments in surveys with citizens to measure their views on algorithmic government. The first obstacle I want to talk about that will motivate by these data is the following: that there's weak support for algorithmic government. And the support is weak in the following way: that citizens support various justifications for the use of algorithms, but they don't support any particular set of justifications strongly. Now, the reason why this is important is because by my lights as a scholar of politics, politics is often about reason given and reason accepting. Politics is not about support for a particular policy or course of action, but it's support for the reasons that a government is doing something. And if people in particular have oppositional reasons to things, these carry much more weight than positive reasons. So the more reasons that one can give to support a policy, the more reasons that are accepted, the more supported a policy will be. So what we did in this study, which we administered in all of these countries, is we presented citizens with reasons for why governments may use algorithms to make decisions. Having described algorithmic decision making to them, we presented them with these 8 reasons. And you can see there's a variety of reasons here. We might use algorithms to reduce the time required to make decisions, to reduce fraud against the government, to reduce the number of bureaucrats or government officials, or to make decisions which are more consistent and less random. If you look across those 8 reasons, you'll see that they sort of break down on a couple of dimensions, or they organize on a couple of dimensions. There's an efficiency dimension, where using algorithms is about making decisions better and faster. And then there's a fairness dimension, which is about things like making decisions which are not influenced by officials' biases, or making decisions which are not influenced by factors like a program recipient's gender, ethnicity, or wealth, to make decisions that are more consistent and less random. And what we find is the following. This is Canadian data now, is that when we present people with these various reasons for supporting algorithms, we find that the majority of reasons are supported, all reasons are supported by a majority of citizens. But most citizens don't support all reasons. In fact, when we break it down, we find something like a quarter of citizens support all reasons, but 10% support no reasons. And in total, something on the order of a third of citizens support less than half of the reasons. Why is it that citizens would support some of those reasons and not others? And the answer with many of these things is politics. Here's what the breakdown looks like. If you look at that efficiency and those fairness dimensions, remember the efficiency one is about making decisions better and faster, and the fairness one is about making decisions that are less biased and more fair. We find that 60% of people accept the majority of the efficiency reasons and the majority of the fairness reasons. But only 10%, or something like 10%, support only the efficiency reasons or only the fairness reasons. And then there's a strong 20% which don't accept a majority of either sets of the reasons. When we look at the data in Europe, we see similar patterns across the questions, though there's actually less support there for any of the items than there is in Canada. But again, we get this similar breakdown where some share of people support all the reasons, a sizable share support 0 of the 8 reasons, and then there's a breakdown in the middle where people are accepting some of the reasons, but not others. If citizens do vary in the sets of reasons that they support for using algorithmic government, why is it? Does it have to do with who they are, with their demographic background? Or does it have something to do with their views of the world? And the answer is that it's actually a little bit of both. So if we look at the Canadian data, this table shows us the following. Older people are more likely to support the use of algorithms. That might be counterintuitive to you, but they might be less aware of some of the negative sides of algorithms. Women are less supportive of the use of algorithms for either fairness or efficiency reasons. Those who have lower income are less supportive. And I want you to think about how often people who have low income are interacting with government decisions on a regular basis. Education is positively related to the use of algorithms on either dimension. So those are those demographic factors. But what about the political factors? And what I want to point out to you here is that the really important one for me is the following, is that the degree to which people hold populist views, that is to say views about whether government can or can't make good decisions and whether we should have effectively more authoritarian and less democratic ways of making decisions, is related to support for algorithmic government. Those who are higher in underlying levels of populism are more likely to support efficiency reasons for government using algorithms, but no more likely to support fairness reasons. Your view of the world and your ideology, in fact, matters as well. That those who are more on the right side of the ideological dimension are more positively inclined to support efficiency reasons than those on the left, and they're more negatively inclined to support fairness reasons than those on the left. It's a complex welter of reasons that people bring to their support or their opposition to government using algorithms. But it's not simply a matter of people knowing more and then being more supportive of these. Our second obstacle to the use of algorithms in government is one that's deeply rooted in a particular feature of human psychology, which is that humans have a strong status quo bias. If you present citizens with, or humans with, one of two policies, policy A and policy B, and you describe policy A as a status quo, they'll be more likely to support it independent of its features or its merits. If you instead describe policy B as a status quo, they'll be more likely to support that. And it turns out that it seems to be the same with the use of algorithms. One thing we investigated in our Canadian data is that we presented respondents with a number of potential algorithmic innovations. We did this across 3 different domains: immigration decisions, small business loans, and tax filing, basically whether a filed tax return would be audited or not. We described to them the way these decisions are made now, that at the end of the process there's a human making a decision. And then we presented them with a number of potential algorithmic innovations. Importantly, none of these innovations took a human completely out of the loop. They were simply meant to enhance the way a human was making a decision. And what do we find? I'll give you just one example. That we find that when we describe to people the way immigration decisions are made, and then when we describe to them a potential innovation that could be brought in to improve the use of information in selecting immigrants, we find that citizens are less supportive of that innovation. Indeed, we present them with 3 different innovations, and in every case, they're less supportive of the innovation over the status quo. It is the same if we talk about not only immigration, but small business loans, and if we talk about taxation. So the bottom line is that when we present people with potential algorithmic innovations to decision-making, enhancements of how public officials might make decisions, across 3 different domains, in every case we find that citizens are less supportive of those algorithmic innovations than they are of the status quo. The third obstacle to the use of algorithms in decision-making has to do with reputation. When you think about what government's doing, it's trying to maintain its reputation over time. And by that what we mean is it's trying to maintain the trust that people put in it to make good decisions. Now there's an interesting feature of human decision-making, which is that when someone makes a decision, and we're evaluating it, we evaluate not only the nature of the decision made, but also our perceptions of the decision maker. Was the decision maker trying to do the right thing? Did they have the right intentions? And if we believe that a decision maker has the right intentions, we're much more likely to forgive a decision that goes in the wrong direction. After all, the people making the decisions are humans. But what we want to show you is that this is not the case with algorithms. That when human beings see an algorithm that's made a decision with which they don't agree, or with which a bad outcome has resulted, they're much more punishing of the algorithm and much less likely to trust it in the future than they are with a human. Let us show you this with a vignette about healthcare decision-making that we've administered in these surveys to citizens. We gave to citizens a little vignette that read the following, and you'll see some bolded text on the screen, and this is where we randomize people to be hearing about an administrator or an algorithm. Let me read you the vignette in the form of an algorithm. Imagine a hospital that has an algorithm that assigns surgeons to patients. This algorithm is a computer trained to make decisions automatically. One day, a surgeon is working on a patient in critical condition when 5 more patients arrive at the hospital in need of care. If the algorithm decides to reassign the surgeon's current patient will die, but the surgeon will be able to save the 5 new patients. If it does not reassign the surgeon, then the current patient will live, but the 5 new patients will die. Having read that, respondents then read, the algorithm decides to reassign the surgeon, or the algorithm decides not to reassign the surgeon. When it reassigns the surgeon, we call that a utilitarian decision because it's interested in the outcome, saving 5 versus saving 1. when it decides not to reassign the surgeon. We call that the ontological choice because it's about the damage that's done effectively by changing one's behavior. And there's three outcomes we're interested in. We're interested in knowing whether or not citizens agree with the decision that was made and recall that they read about the decision either being made by an administrator or by an algorithm. We're interested in whether they would trust the decision maker in the future to make similar decisions. That's about reputation. And then we're interested finally in whether the trust in the decision maker in the future is conditional upon the agreement they had with the decision that it made in that moment. And because we randomize the decision maker, we can separate out decision maker effects, that is, was it an algorithm or a human, from the decision that they made, or we can consider them jointly. Well, what do we find? We find that when the decision that gets made was the utilitarian decision, that is to save the 5 versus the 1, citizens are much more likely to support the algorithm, to agree with the decision that it's made. These are the results in Anglo-American countries. But we find that when the decision is an algorithm, independent of the decision that the algorithm made, citizens are less likely to agree with the decision that it made. Think about that for a second. Irrespective of the decision that citizens made, they're less likely to agree with the decision made by the algorithm. When we ask whether citizens would trust the algorithm in the future, or the decision maker in the future, what we find is the following. The choice that was made, whether it was utilitarian or not in the moment, does not matter for whether they trust the algorithm in the future. What matters is whether the decision maker was an algorithm. And if the decision maker was an algorithm versus a human, they're much less likely to trust that decision maker in the future. Think about the implications of that for a second. When citizens look forward and think about whether they would trust a big decision made by an algorithm or a human, it doesn't matter what information they have about the decision that's been made by the algorithm or by the administrator in the moment. All they care about is who's making the decision. And if it's an algorithm, they're much less likely to say that they would trust the decision it would make in the future. And finally, these are results which come from Europe, and I'll show you that they're just largely the same. That citizens, once again, in these different populations, are in more agreement with decisions when it's made in a utilitarian way, and they're less supportive of it when it's made by an algorithm, irrespective of the decision made. When it comes to future trust, utilitarianism matters a little bit for whether they'll trust the decision maker in the future, but again, it really comes down to whether that decision maker was an algorithm or not. And if it is an algorithm, they don't extend it trust in the future the way they do for a decision made by an administrator. And finally, we ask the question of whether they're more likely to support a decision or to forgive the decision when they have agreed with the decider in the decision that it made in the first instance. But again, we find that it's not the case, that even if you agreed with the decision made by the algorithm or the administrator in the first instance, you're less likely to trust the decision maker in the future if they're an algorithm. So even among those people who liked the decision made by the algorithm or the administrator in the moment, they punish the algorithm much more, or they extend it much less trust in the future. If our first three obstacles to algorithmic government are principally about psychology, the fourth obstacle is about politics. It's about populism. Now, we're going to argue that populism is this kind of flexible political ideology which searches for reasons to generate opposition to government. It's entrepreneurial. And importantly, what we find is that the correlates of populism, nativism or a belief that you should prize people in your own country over others, and a fear of economic loss, are correlated with opposition to algorithmic government. And the potential of those things to be linked up greater for political entrepreneurs to link up the use of algorithms with a belief that government shouldn't be trusted, and that politicians who oppose effectively modern government has the potential, we think, to marshal a broader opposition to automation and AI or to algorithmic government. So I'll just say the following. The first is that there is a widespread apprehension of the effects of automation and AI on job security and prosperity. A large share of citizens worry about the effects of automation and AI on the broader economy and what it will do not only for themselves, but especially for people who they know, their family, and their friends. There's a correlated belief that automation and AI will increase inequality and that it will limit social mobility. In all three of those beliefs, fear of job loss, a belief in increased inequality, a belief in limited social mobility, are correlated with greater opposition to algorithmic government. Indeed, if we look across all of our countries in our sample, what we find is that as fear of job loss due to automation and AI increases, support for algorithmic government declines. In every case where we look, we find that people who are more worried about the broader effects of automation and artificial intelligence are more opposed to the use of algorithms by government. The bottom line is the following. That one, there's no single publicly acceptable justification for employing algorithms by governments. Governments have to deal with the fact that citizens have different sets of reasons for why they think it would be acceptable for government to automate decision making. The second is that citizens have a strong status quo bias against the use of algorithms. The third is that citizens punish algorithms more indifferently than they do human decision makers. That all the work we've done to build up a trust that government can basically do the right thing when the chips are down has to be built in different ways if we're going to use algorithms. And finally, opposition to algorithmic government can grow with that broader societal opposition to automation and to artificial intelligence. There are a lot of challenges to using algorithms in government. There's challenges of supervision, principal-agent problems, implementation, explainability. But at the core of all of those, and more important I think than any other, is a concern about whether citizens will simply agree to government taking humans out of decision-making and putting in algorithms so the government might be efficient, more fair, whatever justifications you wish to use. These are the barriers of citizen consent that stand between us today and much greater use of algorithms and artificial intelligence in government in the future. Thank you.